Welcome to the how-to video for the MOSFET Motor Driver Lab. Okay, you notice there's no resistors in this circuit because this is a voltage control device. Alright, and right now we have a ground on our MOSFET, and we are going to put a positive on this, positive gate voltage on our gate, and it is going to energize and provide a ground to our virtual motor here. So let's try it. And we have essentially the motor is on, grounded, the motor's off. Okay, and you're asking why don't we just hook the switch directly to drive our motor, but this guy will provide much more current and allow us to use microcontrollers and other things in order to control it. Okay, in order to test this motor, let's do a few things. First, I have to correct this voltage. This should be 12. And let's go ahead and copy and paste this guy. I want to go ahead and put the full voltage in here and see what kind of speed we get and see how close we get to it with our pulse width modulation. So let's go ahead and start it and see 46 volts. So we have radians per second to RPM, and that converts it to a voltage reading. So at full speed, we're going to call that 100% on. We're going to be at the speed of 46. We'll say 460 RPM. Okay, so let's go ahead and remove our direct drive on our motor, and let's go ahead and connect it to our pulsing device here, our clock, and let's just do 100. We don't want to go in too fast that it confuses our P-Spice here, so we're going to do a 50% duty cycle and see what we get. And we get a 1.4 at 50%. Reasonable. Okay, so let's go down to 30%. So we're going to change our pulse width here. And well, before I do that, let's go ahead and look at it on the scope too. So here's our 50% duty cycle. And we're on 50%, off 50%, on, off. But the motor is being controlled when it's high, but the transistor's on, but the motor is actually being grounded. Okay, so there's 50%. Let's go ahead and open that up a little bit. Okay, let's go to 30%. So I've already changed it to 30% for duty cycle. And let's turn it on and off, and let's go ahead and take a look at our scope. And we have a single, good. So 30% would be 30% on, 70% off, for a total of 100%. So this here is driving our transistor, but it's grounding it. So our speed should be lower, and it is. A real motor is going to have a bottom voltage where it stops moving. This guy does not have that limit. So let's go up to 70%. Start it. And we're at 2. So our speed is increasing, and let's go ahead and take a look at our signal here. Here we have 70%, 70% on, 30% off. So the transistor is powered during this time, which is providing a ground to the motor and increasing the speed. So let's try try 90%. And we're still at the same. So did I actually change this, or did I just change the frequency? Let's try again. And we're at 2.5, so the speed continues to increase. So we could control the speed by putting a pulse width signal on our transistor and controlling motor speed. Okay, so let's zoom in, view, zoom area, and let's see if we can get it to work. Alright, let's start it. And when it's grounded, it's on. Let's see what happens when we put 12 volts on. It's off. Alright, so this device, the P channel, will be controlling voltage. So we're providing a voltage to our device, but in order to do that we need to invert it. Good. Okay, so let me explain this circuit here. So this is an inverter circuit, and what we're doing is we're going to provide a high, which would be 5 volts. So a 5 volt positive signal will go in this direction and light the red. So we'll give us a high. So when it's red, that would be a 1. Okay. When this one's activated, it'll provide a ground through our green and go this direction and provide a low. So, and it's an inverter because this voltage here at our switch will be inverted. Let's see if we can get it to work. And it is not. Okay, so there's a couple things we could do. Let's go ahead and tamper with our LEDs. Current on, let's make that 2 and make this one 2. We could change our resistors too, but let's, alrighty, let's try again. There we go. We got a low in, we got a high out. We got a high in, and we have nothing. Alright, so let's take a look. We have high, and again I put the transistor in. I flipped it unnecessarily. Let's whip him back. Come on. Okay, that'll be better. All right, there we have it. So there's we have a high in, low out. Let's try the other one, and we have a low in, high out.